You're listening to the Anesthesia Patient Safety Podcast, the official podcast of the Anesthesia Patient Safety Foundation. We're bringing you the very best from the APSF newsletter and website, as well as the latest information in perioperative patient safety. Thanks for joining us.
Hello, and welcome back to the Anesthesia Patient Safety Podcast. My name is Alli Bechtel, and I'm your host. Thank you for joining us for another show. Happy New Year's! It is 2024, and to kick off the year, we are going to return to the past, specifically the October 2023 APSF newsletter and the Rapid Response column. Our show today is part 2. Part 1 aired last week for our last show in 2023, and we discussed electronic interference in the operating room and recurrent anesthesia machine malfunctions. We are continuing the conversation today. Before we dive into the episode today, we'd like to recognize BD, a major corporate supporter of APSF. BD has generously provided unrestricted support to further our vision that no one shall be harmed by anesthesia care. Thank you, BD. We wouldn't be able to do all that we do without you. We are going to pick up right where we left off last year with intraoperative anesthesia machine malfunctions. How many anesthesia machine checkup procedures have you completed in 2024? Let's review the updated recommendations from 2008 that were covered in the spring 2008 APSF newsletter article, New Guidelines Available for Pre-Anesthesia Checkout by Jeffrey Feldman and colleagues. To follow along with us, head over to apsf.org and click on the newsletter heading. Fourth one down is Newsletter Archives. Then scroll down to spring 2008, and there you will find the article. I will include a link in the show notes as well. To kick off the new year, here are the requirements for safe delivery of anesthesia care. Reliable delivery of oxygen at any appropriate concentration up to 100%. Reliable means of positive pressure ventilation. Backup ventilation equipment available and functioning. Controlled release of positive pressure in the breathing circuit. Anesthesia vapor delivery, if intended as part of the anesthetic plan, adequate suction, and the means to conform to standards for patient monitoring. If you turn your attention to Table 1 in the article, this is a list of the recommended essential steps in a pre-anesthesia checkup procedure that needs to be completed daily or after a machine is moved, serviced, or vaporizers are changed. Let's review it now. Verify auxiliary oxygen cylinder and manual ventilation device are available and functioning. Verify patient suction is adequate to clear the airway. Turn on the anesthesia delivery system and confirm that AC power is available. Verify availability of required monitors, including alarms. Verify that pressure is adequate on the spare oxygen cylinder mounted on the anesthesia machine. Verify that the piped gas pressures are greater than or equal to 50 psi. Verify that the vaporizers are adequately filled and, if applicable, that the filler ports are tightly closed. Verify that there are no leaks in the gas supply lines between the flow meters and the common gas outlet. Test the scavenging system function. Calibrate or verify calibration of the oxygen monitor and check the low oxygen alarm. Verify carbon dioxide absorbent is fresh and not exhausted. Perform breathing system pressure and leak testing. Verify that gas flows properly through the breathing circuit during both inspiration and exhalation. Document completion of these checkout procedures. And confirm the ventilator settings and evaluate readiness to deliver anesthesia care. Table 2 reviews the recommended essential steps that are needed to be completed prior to each procedure, including in between every case. These include verify patient suction is adequate to clear the airway, verify the availability of required monitors and alarms, check the vaporizers are adequately filled and the filler ports are tightly closed, verify carbon dioxide absorbent is not exhausted, perform breathing system pressure and leak testing, verify that gas flows properly through the breathing circuit during both inspiration and exhalation, document completion of these checkout procedures, and confirm the ventilator settings and evaluate readiness to deliver anesthesia care. Anesthesia professionals and technicians need to work together to complete these essential steps in order to provide safe anesthesia care. Now let's return to the October 2023 APSF newsletter article, Recurrent Intraoperative Anesthesia Machine Malfunctions by David Cortman and Linda Liu. You can find this article by heading back over to apsf.org and clicking on the newsletter heading. Third one down is rapid response to questions from our readers. And then scroll down until you get to our featured article. I will include the link in the show notes as well. The authors report that despite following the recommended anesthesia machine check, there were 2 critical malfunctions that occurred at their institution. During both machine failure events, a power loss to the anesthesia monitor display unit occurred, leading to the loss of all ventilation parameters, failure of mechanical ventilation, and inability to administer volatile anesthetics. During these cases, the anesthesia teams were unable to immediately determine the cause of the anesthesia machine malfunction. Eventually, a loose connection was identified behind the anesthesia monitor display unit. Check out Figure 1 in the article for a picture of the 3 cables attached to the back of the anesthesia monitor display unit. Cable A, the system power interface, Cable B, the system signal interface, and Cable C, the serial port standard interface for external communication to electronic health record. In one case, there was a missing securement screw where Cable A was connected to the display unit. For the second case, the cables appeared connected, but there was a loose screw found with closer inspection. After firmly reinserting Cable A into the back of the monitor, the anesthesia machine went through the startup cycle. At this point, the anesthesia monitor display showed a nonspecific error screen that read, "Internal problem prevents normal operation," with instructions to manually ventilate with alternative oxygen control and turn off and then on again the anesthesia machine. Check out Figure 2 for a picture of this error message. Both of these cases required the use of alternative oxygen control and total intravenous anesthesia following the power failure. After restarting the machines in both cases, the anesthesia teams were able to use the anesthesia machines with normal function restored, and there was no patient harm. Further investigation of the error history after the events revealed these 2 errors in the log. DU to PSC COM error and power control COM fail. These errors point to a disconnection of the communication cable between the anesthesia controller board and the anesthesia monitor display unit. Check out Figure 3 in the article for a view of the error log. Indeed, it was possible to recreate this machine malfunction with a biomedical technician by slightly loosening the screw, leading to a transient cable disconnection with movement of the monitor arm. This results in the anesthesia machine failing to complete the startup sequence until the communication cable is secured. Cable C disconnections may lead to a similar error, which will interrupt anesthesia machine external communication to the electronic health record. The authors report that checking the communication cables is listed under visual inspection procedure, which is performed on the 12-month preventative maintenance schedule. Keep in mind that these loose connections will not be detected by the automated machine check or standard pre-induction checklists. This type of failure may be more likely with older anesthesia machines. The authors report that their machines are 15 years old, as the screws continue to disengage over time. One possible solution would be to place a retainment clip as a redundant securement mechanism. This redundancy is a safety innovation that may be necessary to help prevent failure of this critical system during anesthesia care and to help keep patients safe. Going forward, improved designs can help prevent errors, especially for rare problems that routine checklists are unable to detect. The authors must continue to use the older anesthesia machines at their institution, but the biomedical department has retightened the screws for all of the anesthesia machines and advocated for a proactive preventive maintenance schedule to help prevent cable disconnections and machine failures going forward. For anesthesia professionals using older anesthesia machines, there is a call to action for heightened vigilance about this potentially catastrophic vulnerability. Have you experienced a cable disconnection or loose screw leading to machine failure at your institution? This is definitely a very important threat to anesthesia patient safety. Thank you so much to the authors for highlighting this. Before we wrap up for today, I also asked Cortman what he hopes to see going forward in 2024 and beyond. This is his response.
Advancements in anesthesia technology have made our practice increasingly safe, although nothing is without risk of failure. We should expect to continually reduce the incidence of intraoperative anesthesia machine failures by improving our checklists and maintenance processes, as well as the engineering and design. Anesthesiologists can, as the end user, play a critical role in the design process to ensure the next generation of equipment is safer than ever. In our case, by identifying a single point of failure and notifying the manufacturer, perhaps an update to the maintenance guidelines and a redesign of the cable retention mechanism can be implemented to prevent this problem from recurring.
Thank you so much to Cortman for contributing to the show today and highlighting the role that anesthesia professionals have as the end users for anesthesia equipment to help make the next generation safer, which is such an important step for helping to keep patients safe during anesthesia care. If you have any questions or comments from today's show, please email us at podcast@apsf.org. Please keep in mind that the information in this show is provided for informational purposes only and does not constitute medical or legal advice. We hope that you will visit apsf.org for detailed information and check out the show notes for links to all the topics we discussed today. Have you made any resolutions for 2024? We hope that continuing to provide safe anesthesia care is at the top of the list. There are so many resources from the APSF that can help you with this goal. Check out the patient safety resources over at apsf.org, which include lookalike drug vials, the Anesthesia Patient Safety podcast, the APSF video library, news and updates, in the literature, the APSF Technology Initiative with courses on low-flow anesthesia and quantitative neuromuscular monitoring, Emergency Manuals Implementation Collaborative, the Perioperative Multi-Center Handoff Collaborative, patient guides, the COVID Resource Center, international resources, and helpful links. Until next time, stay vigilant so that no one shall be harmed by anesthesia care.